you'll have time for the class practice. All right, so we're on 3A.4 compound interest. This is the last section that we need in our unit 3A before we take our checkpoint on Wednesday, oddly enough. So let's talk about compound interest. Compound interest formula. So the compound interest formula means that someone recognized the pattern and did all the hard work for us, correct? So that makes it easy for us because we just have to identify from the problem what we have. So your A is your balance or your initial amount, right? Your P is your original amount invested. Your R is your interest rate in decimal form. Remember to move our percentage to a decimal. We move 2 decimal places to the, I'm going from percent to decimal. To the left, 2 decimals to the left. Always think Beyonce, okay? N is the number of times per year interest is compounded. So when you're saying compounded per year, it means how many times is that happening over a year? If it said once a year, then it's 1. If it says every month, that means N equals 12. If it says semi-annually, that means N equals 2. If it says quarterly, that means N equals 4. Does that make sense? 4. All right. So just keeping that in mind based on the problem. All right. So let's look at our first example here. So our first example, it says the amount of 500 is deposited into account that pays 9.5% compounded monthly. What is the balance in the account after 3 years? So the first thing we're going to do is talk about what are we given. So that 500, which variable is that? My P. 500 is going to be my P. Does that make sense? The 9.5% is my what? My R, my rate. So that's your R. And again, in decimal form, that's 0.095. Okay? Because it says compounded monthly, that means that my N equals 12 because there's 12 months in 1 year. Does that make sense? And it wants to know what is your balance going to be in 3 years. So that means it wants to know your T equals 3. So I have 4 out of the 5 variables that is needed for this formula. So I'm going to take that information and plug it in. So we're looking for the amount after 3 years, which is going to equal 500. That's our P times 1 plus our rate. Well, that got a little weird there. 0.095 divided by our N, which is 12 to the N times T. So 12 times 3. Okay? Because you're using the calculator, you can just plug this in as it is. There's no need to simplify beforehand. You just grab the calculator and you plug it in as it is. It is very simple. So I have 500 times 1 plus 0.095 divided by 12 to the 12 times 3. Hit enter, and it tells me that after 3 years, how much money would be in my account. $664.14. That is what your A of 3 equals. How do you feel? Pretty straightforward, right? Because again, someone's already done the hard work to figure out the pattern of what's taking place. Your job now is to accurately use it. Capiche? All right, so let's make sure you understand. So here is your example to work at your group. You're going to read through. All right, so I heard a lot of good conversations going on. So let's kind of talk about what did you identify about the problem? So from this problem, what was my P, my initial amount? 150. What was my R? 0.005. What was my N? 1. Perfect. What was my T and how did you find it? And how did you get that? 1994 minus the best year ever. I said what I said. Because I'm here. I was. Best year ever. All right, here we go. So now we're looking for A of 6. So now do we have everything we need to find A of 6? Yep, remember, someone else already did the hard work for us. We just got to plug and chug. All right. Will it bother you if I don't divide by 1? No. No, because there's no point of dividing by 1 because it's going to be its self. Will it bother you if I don't multiply by 1? No, it's not. It's going to be the same thing. So this is where you came down to, and this is what you should have put in your device. Did we? Because you don't need to simplify if it's going all into the calculator. So you have 150 times 1.0. I couldn't write it with the addition, those extra. And you should have gotten 231 and 50 cents. How'd we do? We did it. There we go. So we got $231.50 is what it is worth 6 years later. Yes? All right. Our next example is going to be an example of when you are given the A and not the P. So we have to solve for the P. Okay? So it says, how much would you deposit in an account, Pablo, that pays 6.25% interest, compounded semi-annually, to have a balance of 5,000 in 15 years? Okay? Semi-annually means that they're going to choose your compound date. Does that make sense? But it's only going to happen twice. So we're going to go through and label what we have. It first starts off telling us our 6.25, which is our rate. So we have 0.0625. Agreed? And then we have compounded semi-annually. So that means n equals 2. They get to choose when it happens. Like they may say in June we'll compound and then in August or whatever, but it's twice. All right. Then it gives us our A because we want a balance of 5,000. And then it tells us our T, and our T equals 15. So we've identified 4 of the 5. And now we got to do the equation. So we have 5,000 equals, we don't know our P, right? That guy we don't know. Times 1 plus 0.0625 divided by 2 to the 15 times 2. Again, because you're putting this all in the calculator, do you need to simplify? No. No, you just have to know what is the inverse operation of multiplying. Divide. So in order to get P by itself, we're going to have to divide by this entire thing. Does that make sense? Yes? Okay. So we're going to divide both sides, and I don't want to rewrite it, so I'm putting quotation marks to let you know that this is what that would be, right? So I'm going to divide 5,000 by this entire thing. If you want to simplify before, could you? Why, yes, you can. But is it necessary? No, it's not. Okay. All right. So here I go. I'm going to go to my handy dandy calculator. Again, you can do the same thing on Desmos. Your calculator has the feature of becoming a fraction. Mine does not. So I'm going to write it using parentheses. So I have 5,000 divided by, and my denominator is 1 plus 0.0625 divided by 2. All of this carried to the 15 times 2, which is 30. Does that make sense? I hit enter, and it says that my initial amount had to be what? P had to be $1,986.33. Okay. Was that terrible having to solve for P? No. The difference here is that P is a coefficient. It is not a power, so we didn't have to use log. Does that make sense? The P was the coefficient, so it wasn't necessary to use log. Got it? Okay. Do you guys think this is going to be any different if I was depreciating? What do you think is going to be the change from a growth to a decay? What's going to, that's it. That's literally all that changes. What if the value is decreasing? The only factor that changes is the plus sign. It becomes a minus. Does that make sense? As the only thing that changes. Other than that, you're following the same thing. And that makes logical sense, right? Because I'm not gaining anything, I am losing. So quickly figure out how much is this car depreciating or has depreciated by. Go. All right, let's see how we did. Okay, so starting off with the problem, we are given our P, correct? 12,500. We then are given our R, which is 0.20. Our N, which is year, so just one. And it tells us our T, which is 3. So I have everything I need to figure out the amount of the vehicle after. So we have our A of 3. We have 12,500 times 1 plus 0.20, because is there any reason for me to put the N? Nah. To the 3. Yep. You knew I meant that. I forgot to put one line in it. That's why I didn't get the answer. Ah, that would make a difference. All right, so we're gonna type it in. 12,500 times 1 minus 0.20 to the third. And the car will be worth, still don't know what you're doing there, but $6,400. It's just, that's what? Wrong here. Oh, good job. I think you may have typed something in. What else is showing? It should be 0.20 because it's 20%. I swear. 2% would be, hey, Khalil, you're recorded, buddy. Just letting you know. Yeah. Excuse that child. I don't know what to say. Call his mama. No. Because I can't edit this. All right, what was my final answer? Now, Khalil? Thank you. Easy enough? All right. Okay, on to the little half sheets. You feeling it today? You saw me write it on accident. It happens to the best of us. All right, interest compounded continuously. So compound with quarterly, annually, monthly, semi-annually, we have a in value, right? Yep. Now, when it says continuously, there's no more in value. What ends up happening is that we're using E now. Because remember, E is our number that goes on forever, right? It's our natural exponential exponent, or base, natural base, I'm sorry. And so now your formula changes a little bit. Okay. And that's because once it says continuously, compounded continuously, that means every nanosecond, every second, every minute, every hour, you're earning interest on that money. Does that make sense? Or losing, either way. Okay. So A is our ending value. Our P is our original value. Our E is our constant. Remember, E is just a number. So it's roughly that. And our R is our annual interest. What are we earning in decimal form? And our T is our number of years the money has been interest. If it gives you a month, then you have to put that over 12. Does that make sense? So if it says 4 months, that's 4 out of 12, because everything is in terms of years. No matter what, everything is in terms of years. Okay. All right. 21 is years. So here we go. Terry deposited $100 he got for his 5th birthday in savings account that compounds continuously at 5%. Today is his 21st birthday and he wants to withdraw the money. How much does he have? Okay. So the first thing we're going to do is identify the variables, right? And our variables are P is 100. Yes. R is 0.05. And our T is what? 16. 21 minus, which is 16. Do I have everything I need to plug into that formula? E is already there. E is a number of its own. Just discussed that. So we're looking for the amount after 16 years. So we have 100 E, and then your R is 0.05 times your T, which is 16. So your P, your R, your T. Yes, E is just a number. I call this the PERT formula. Okay, so we're going to go to the calculator, and E is already in the calculator. You can. If you're using the handheld, you press second LN to get the E. So you have 100. Here, press second LN, and there's your E, 0.05 times 16. So after 16 years, he now has how much in his account? $222.55. He said he still wants that money. Give me my money. Okay. How do you feel? Okay. All right. Make sure you got it. Here's yours. All right. 1,500. Yes. 0.095. And you have T equals 5 and 25. Okay. So you plugged in the first one, just like so. And you should have gotten $2,412.02. You plugged in the second one, and you should have gotten $16,126.52. Can we compound continuously? Yes. We just gonna ignore him. All right, there's partner classwork. You're gonna need your own notebook paper, and you're gonna open the assignment up on Canvas. You're gonna need your own notebook paper. Yes, you're turning it in. No, those are your notebook. Okay. And you should be able to finish this before the end of class and turn it in. That's why it's classwork.